All right, we're going to continue our work with circles, and today we're going to shift from talking about lengths like segments and lines and things like that to arcs in a circle. So you can see that's our next two standards here. I can identify and solve problems involving types of arcs in the circle, and then we're going to talk about we talked about circumference in our last lesson, and we're going to talk about arc length of a circle today. So now to kind of get you thinking about that and how that might relate to what we're going to talk about today, I would like you to find the circumference of a circle with a diameter 10 for the opener, and then answer this question about how far you would walk if you only walked halfway around the circle or only a fourth of the way around the circle. And then think about kind of how you figured that out. So go ahead and pause the video, do that, and then flip it back on, and we'll see how you did. All right, so remember that your circumference formula, all right, is pi d if we have the diameter. So if you just plug that in, you get 10 pi, and it's more than okay just to leave it in terms of pi. You can leave it as an exact answer. That's always good. But if you used a decimal, you should get about 31.4. Now, how far would you walk if you only walked halfway around the circle? Well, circumference is all the way around, right? So if I only walked halfway around the circle, all right, I would divide my circumference by 2. So 10 pi divided by 2 would be, all right, 5 pi. All right, or 31.4 divided by 2, you should have gotten somewhere like, 17.4, or sorry, 15.7, something like that, about that. Now, if I only walked a fourth of the way around the circle, well, we would take whatever the diameter is, and we would divide that by 4. And if I leave this as an exact answer, right, I would just reduce this fraction, right, same way as normal, like 2 goes into both 10 and 4, so that's 5 halves pi, or you would take 31.4 and divide that by 4. And what that really is the arc length, right? So how far along the arc did you walk? Because we may not walk the entire distance around that circle. All right, so now, just like in the last lesson, there's a little bit of terminology we have to get through. So let's go down and just start doing that. Okay, so arc, all right? So if we think about an arc, all right? So an arc is, all right, moving from, and I'm just gonna put a couple of points on our circle here, okay? So an arc is the continuous part of a circle between 2 points, all right? So like if I go from B to D, all right, so that's an arc, all right? So the continuous part of a circle between 2 points, all right? So we would say arc BD, and we put a little mark over the top like this, so BD, and then we do the little arc mark like that. So that's how we make the symbol for an arc. All right, a semicircle. So semicircle is half of the circle, all right, or half, all right, of the entire distance around when we think about degrees. So it's 360 around, all right, so a semicircle would be only 180 degrees, all right, so that's half of a circle. All right, so that implies that it's 180 degrees, right? Okay, so that would be like arc CB. Okay, now we have different lengths, and we kind of relate it all to our semicircle, right? So we have a major arc, and that's an arc, all right, with a measure greater than 180 degrees. And then we have minor arc, all right, and that's an arc with a measure less than 180 degrees. All right, and once again, if you need to pause the video to write down the notes here and then turn it back on to get the rest of the explanation, feel free to do that. All right, so now, so notice I put BD here as my arc earlier, right? Well, how do I know I'm going from B to D on the short path or the long path? All right, and that's how we name, all right, our main minor and major arcs. So if it's a minor arc, all right, we're going to label it, all right, with 2 letters. So like when I label BD, we are assuming it is the shortest path and that it's going to be less than 180 degrees. So we're assuming that with 2 letters, it's the minor arc. Versus the major arc, if I wanted to go the long way, I put in a 3rd letter to signify that. So I would do like BCD. And that means I went all the way around here, and that would be my major arc. All right, so we want 3 letters here, right? So once again, if I look at, all right, a major arc and a minor arc, all right, so a major arc is more than 180 degrees, right? So if I imagine a diameter through F, right, so FE would be a minor arc, right? FH would be a minor arc, all right? Those are definitely less than 180 degrees. So if I wanted the major arc from F to H, I would include G here. So I would go F, G, H. And I still put that arc mark over the top. All right, and that signifies I'm taking the long route away, around the circle to get from F to H versus the short route. So minor arc, 2 letters, we're assuming it's less than 180 degrees. Major arc, 3 letters, and it's more than 180 degrees. Okay, so let's flip the page here, and let's look at, all right, okay, the next thing that we have here, which is how do we measure an arc? And when we talk about arc measure, we're measuring this in degrees, okay? And the measure of our minor arc, all right, is equal to its corresponding, all right, central angle. All right, so every minor arc can be formed by a central angle. So notice we have RST as our central angle here. All right, it has a measure of 50 degrees. And so notice we still use the same little m like we do with an angle because we're talking about degrees here. We see that RT, all right, 2 letters, it's the minor arc. So we know it has to be less than, all right, 180 degrees. So that's 50 degrees. All right, so now the major arc, we have something called a reflex angle. So to its corresponding reflex angle. All right. And basically what that is it's what's left of the central angle. All right. So if we take the central angle away, so notice we have TQR here, right? Well, the entire distance around in degrees is 360 degrees, right? So if I take 50 away, we know that's 310 degrees. So the reflex angle, all right, is really the angle formed or what's left once we take away that measure of that central angle. And then we talked about this just a second ago. All right, the measure of a central angle is always 180 degrees. All right, so if we want to know the measure of an arc, we have to find, all right, its corresponding central angle. Okay, now arc addition postulate. Now this ties in, we've talked about segment addition postulate, we talked about angle addition postulate, right? All right, so the measure, and you're going to see that this just follows right along with that. So the measure of 2 adjacent arcs, all right, is equal to the sum of the individual arcs. All right, okay. All right, so just to make sure we're good. So adjacent arcs, all right, what does that mean? All right, that's 2 arcs that share a common point on the circle. Okay, so when we look at what we have right here, okay, so, all right, so arc BC and arc AB would be adjacent. All right, so BC and AB, they're adjacent, they share point B. All right, and if I wanted to know the measure of arc ABC here, right, I would just need to know, right, that it's going to be the measure of arc AB plus the measure of arc BC. All right, so whatever this happens to be plus whatever that is, that would give me the entire arc. And that makes sense based on everything else we've done. That was true for, all right, angle addition postulate, all right, and that was true for the segment addition postulate. So this just continues working with some of those big ideas, right, that we've talked about. Okay, the next type of angle, all right, an arc that we're going to talk about is an inscribed angle. So an inscribed angle is an angle formed, by 2 chords with a common point on the circle. All right, and so basically, all right, if we form an angle with 2 chords, all right, okay, and their vertex is on the circle, all right, so that common point on the circle, we're really saying that's the vertex, that's an inscribed angle. Now notice if I extend this angle to where the chords, all right, intersect the circle here, I create an arc, okay? And the measure of an inscribed angle is always equal to 1/2 of its intercepted arc. Intercepted arc. Okay, so if arc GH, is equal to 80 degrees, okay, so the measure of GF is equal to 80 degrees here, and I should have put my M's up here. I've gotten a little hurry there. All right, okay, then we know the measure of angle GEF is going to equal to 1/2 of that, so this would equal to 40 degrees. All right, so every inscribed angle, all right, is going to equal to half of its, all right, intercepted arc. Okay, so that's the, all right, you can see that with circles, there's a lot of terminology, all right, a lot of different things, all right, but a lot of the relationships, right, are pretty straightforward. You're just going to have to know those. All right, let's talk about arc length. All right, so flipping the page to page 8 here. Arc length, all right, is the length, all right, of the arc formed by a central angle. All right, this is a percentage of the circle's circumference. And so this is really what the opener was about. Now, the difference was between arc length and the opener was, like I said, oh, well, what if you only went 1/4 of a way? What if you only went half of the way? So now what we have to do is we have to figure out, okay, so how do I interpret that based on, all right, the information in my picture and about that circle? And then what we have to do is think about, okay, the central angle represents, all right, a part of the circle. And that central angle out of 360 is going to give us that percentage, all right, of the circle that we're talking about. Okay, so to find the measure of an arc, the first thing we have to do is we have to find, all right, the circumference. We have to know the entire distance around the circle first. Okay, and so now what we do next is we want to multiply, all right, the circumference, all right, by the percentage of the circle formed, all right, by the central angle. All right. Okay, so circumference times the central angle divided by 360. So notice if I do 360 divided by 360, that's 1. That means I went all the way around the circle, which gives me just its circumference. That makes sense, right? If I did a semicircle, or if I only went halfway around the circle, that's 180 divided by 360, and that would be half of the circumference. All right, so the central angle divided by 360, all right, is going to give us, all right, that percentage. All right, and that's how much of the circle we're looking at. So if we go up to the examples up here, right, you can see that, okay, our radius is 13, all right, and we know that circumference, we said earlier, is pi times diameter. So if my radius is 13, the diameter is 26, so the circumference of this circle would be 26 pi. Okay, and that was if I went all the way around. If I walked all the way around, I'd go 26 pi units around that circle. But notice, I'm only traveling this far. So what percentage of the circle is that? Well, I only went 60 degrees here. All right, so I only went 60 out of 360 degrees. So my arc length would equal to my diameter, which is 26 pi, times 60 out of 360. All right, so 26 pi, right? And so this is 26 pi, and 60 over 360 is just 1/6. So this would be 26 pi over 6. Now, what we would like you to do, right, is then just use good, all right, number sense here and just go ahead and reduce that fraction if possible. So 26 and 6 are both even. I can divide both by 2, and that would mean that that arc length would be 13 pi over 3, all right, if I left it in exact units. And pretty much do that unless you really need to convert it to a decimal. All right, so for this one, notice I definitely walked a lot farther, right? I definitely went more than half the circle because I'm up to 225, right? Okay, and so once again, I can see that my radius is 12. That means the diameter is 24, which means then that the circumference is 24 pi. Okay, so now once again, what would that arc length be? Well, if I went all the way around, it's 24 pi. But I didn't go all the way around, I went 225 out of 360. All right, and then if you were to reduce that, all right, I'm just going to save a little bit of time, and we would get to 15 pi. All right, so that's your introduction to arcs, all right, and arc length in a circle. All right, what we will do is we'll just pick up with on page 8 here with some examples, and we'll go through those and show you exactly how to use, all right, central angles and inscribed angles and all those good things in class. So if you have any questions about anything, highlight those and bring them to class, and we'll see you then.